Hello everybody and welcome back. We're all the way up to question number 4 on the 2004 Euclid. And just a quick reminder in case you just stumbled upon this video, if you would like to try a copy of this contest, you can click the link in the description. You can also click the second link. It'll take you to the CEMC website and you can take a look at all their stuff, but more importantly, you can take a look at their solutions to the problem as opposed to the ones that I present. Okay, CMC, great people. They have a good site filled with lots of contests and things that you can try out. But let's get to question number 4. So it's a two-parter. There's a light bulb and a written portion, just like the last question 3. 5's that way. I think 6 and 7, but then 8 we start getting into pure written, and that's fine. That's the general makeup of the contest. So all the way back here to question number 4. 2 fair dice, each having 6 faces numbered 1 to 6, are thrown. What is the probability that the product of the 2 numbers on the top faces is divisible by 5? Okay. Now they're fair dice, which means that any of the 1 to 6 can pop up when you roll just one of them. And when we roll 2 of them, there's 6 possibilities for each dice. That's 36 possibilities. Because each of the dice are fair, the total probability is fair. So any one of those 36 outcomes, 5 on this die, 1 on this die, or 3 on this die, and 3 on this die, each of those is equally likely. Okay, and because they're equally likely, we're able to sort of, what it's called sort of an equiprobable sample space. And what you can really do is ultimately you can get, I'm going to put a bit of a preamble, but the probability is the number of desired outcomes over the number of possible outcomes. And there's 36 possible, as I already said, so we just need to figure out the number of ways that the top faces can have a product that's divisible by 5. So I might say something like, since the dice are fair, any of the 36 outcomes is equally likely. So the probability is the number of desired over the number of possible. Okay? I see a lot of people when it's a probability question on a contest, especially some more recent ones since there have been changes to at least the North American curriculum. I see a lot of people just saying, oh, it's a probability question. It's the number of things I want out of the total number of possible things. And that's only true if everything's fair, if all the outcomes are equally likely. Okay? But if I had, say, a weighted dice, so there was a weight right behind the 6, so it was more likely 6 would be on the bottom and 1 would be on the top, you might say something like, well, we'll see the 2, 3, 4, or 5 with equal probability, but the 1 maybe is 3 times as likely as those, and it's 5 times as likely as the 6, that sort of thing. So there are ways to have probability questions where it's not just count the number of this thing and divide by the total number of all the things. Okay, that happens a lot when you're flipping a fair coin, when you're rolling some fair dice, when you have what anything in the question suggests that it's fair, the choices are all equal, then you can do this. Okay? But since I don't want people falling in the trap of saying, oh, probability is just count this, divide by counting this, because that can really burn you on some questions. I think recently, what was it? The CSMC, I think, had a probability question. So the 2016 Canadian Senior Contest had a probability question, and a lot of people were doing this out of this. And that was not the case because there were certain things were more likely to occur than others. I'm not going to get into that question because we're doing another one right now. But that's something just to be aware of. It does work in this case because, as I say, the dice are fair. Okay. So we just need to work out the number of ways that the product of the faces is divisible by 5. And this actually isn't so bad. One thing you could do if you wanted to, you could list out all 36 possibilities and just sort of say, okay, that one gives me a product that's a multiple of 5, that sort of thing. And that would be fine, but we can actually narrow it down. One of the faces has to be 5. Okay? Because numbers 1, 2, 3, 4, 5, 6, if you take any two of those and both of them aren't divisible by 5, like if both of them are not divisible by 5, your product won't be divisible by 5. 5 is prime. If you said you wanted a product that was divisible by 4 or by 6 or something like that, those are composite numbers. You can easily get a product that's divisible by 6 having 2 and 3, and that's not divisible by 6. But 5 is prime. We could even say that, although it's not really going to earn us a whole lot of part marks. So this works because 5 is prime. If we had sort of a 10-sided dice, this also wouldn't work, because you could have 10, which is not going to be 5, but you'd still get a product that's divisible by 5. But this narrows things down. Let's let the first die be 5. So we can get 5 and a 1, a 5 and a 2, 5 and a 3, 5 and a 4. You get 5 and a 5. This one's going to come back to us in just a moment, because he's both die being 6. 5 and a 6. Or we could have the second die roll be the 5. Uh, 4 and 5. 5 and 5. There he is again. He showed up in both lists, so we don't want to count him twice. So we only count him once. And that's 6 plus another 5, 11 possibilities. So the probability is 11 out of 36 that the product of the top faces will be divisible by 5. Okay? And that's as simple as it needs to be. We explained why we can do this, because they're fair dice. We even mentioned that 36 outcomes. We don't really need to explain that one. But if you wanted to, it's 6 possibilities for first die times 6 possibilities for second die, that sort of thing. Okay. So now B part. This is the one that we actually need to explain. If f of x is x squared minus x plus 2, g of x is ax plus b, and f of g of x is 9x squared minus 3x plus 2, determine all possible ordered pairs A, B which satisfy this relationship. Okay. So first of all, I'm noting a couple things. One, it's got functions in it, and functions tend to scare people away. Functions aren't really done in and of themselves. You see a little bit of it sort of in grade 10, but they're still doing parabolas, which are y equals whatever. You see functions more when you do sine and cosine and trig stuff. But you'll see functions in grade 11 and grade 12. And so functions can scare people just by sitting there being functions, especially when it's things like logs. Logs tend to really freak people out, and they tend to shy away from the log questions. But, you just sort of break it down, approach it as you need to. The big scary guy here is f of g of x, but if you sort of just calmly take your g of x, ax plus b, and plug that into your f of x, you'll get your expression just fine. The other thing I'm noting is questions on the Euclid, especially later questions, tend to have their concepts connected. You can have question 1, 2, maybe even question 3, where at least the connecting thread, if there is one, is very insubstantial between sort of A, B, and C parts. But as you get later on, like part 6 might have sort of a little cutesy semicircle and triangle thing, and then part A might have something like that, and then part B would be a big circle that you have a bunch of triangles in, but the circle theorems that you need in both cases to solve things might be the same. So with that in mind, I'm thinking part A, what did we do? Well, we did some probability and some dice, and I don't really see that connecting, but what I do see connecting is the product, this divisible by 5 thing. So I'm thinking maybe I'll need to consider some divisibility, maybe some primes, or maybe this is just a case where they had 2 sort of good questions and just put them together to make question 4. That does happen. Okay, there doesn't have to be a connection. And even if we do it one way, there might be another way that they've thought of that has the connection that we just can't see. So don't force yourself to say, oh, that can't be right. That doesn't connect with what we did in part A or part B, that sort of thing. Just do the questions, but sometimes A part can inform how you do B part. Sometimes B part can inform how you do C part or D part, that sort of thing. Okay, so I'm going to be on my guard for divisibility, for products, for breaking things down like that. Okay. That said, let's get to plugging this in. So f of g of x, we're told that that's 9x squared. I think it was minus 3x plus 2. Let's just quickly go back and check. Good memory. So that is the same as f of g of x, and that comes about by plugging g of x into f. Now, f was x squared minus x plus 2. So we take g of x, ax plus b, and we put that in. Okay. One thing I notice immediately, these 2's cancel out. I mean, I was going to first expand some stuff out, but I'm going to cancel out these 2's right away. That'll mean that our constants b might have to be something like 0 or 1 or something so that they cancel. Anyway, so let's expand out. A squared x squared plus 2abx plus b squared. Be careful with the minus sign. It does have to go over both of them. Alright. So this has to match up. One of the first things that we can note is a squared has to be equal to 9. But we'll deal with that in a moment. Let's clean this up ever so slightly. Because of divisibility, I'm going to write this as a 2b minus 1. I don't know whether or not that'll make a difference. And then we've got, as our constant, b squared minus b. And we're going to write them together like that in brackets. So the coefficients have to match for the functions to be equal. So 9 is going to be the same as x squared. That limits what a can be. Negative 3 is going to be a times, not 3b, 2b. And then, 3 is a prime, so maybe something, I don't know. And then finally, 0 has got to be equal to b squared minus b. Okay, so we've got some great things to look at here. I'm going to flip over to the other side of the page. 9 equal to a squared. A is going to be 3 or negative 3. Other thing I notice immediately, b squared minus b. That's going to be b times b minus 1. So either b is 0 or b minus 1 equals 0, but that's really just b equals 1. So we have a bunch of possibilities, and we wanted what? Ordered pairs. Okay, we want ordered pairs A, B that satisfy the relationship. So we have candidates right now. We have 3, 0, negative 3, 0. We have 3, 1, negative 3, 1. But I'm betting this middle condition, this negative 3 equals A 2B minus 1 is actually going to affect what we could possibly have here. Okay, so I think the easiest thing to do is just let's make a chart. It's the written one, so I got to explain what I'm going to do. Of A, B values and A 2B minus 1 to see which give 3. So I'm going to have my A's here, my B's here. So my A's could be 3 or minus 3. My b's could be 0 or 1. So 3 times 2 times 0 minus 1, that's 3 times negative 1. That's equal to negative 3. That's great. That's one of the ones we want. Negative 3, 2 times 0 minus 1. That's going to be negative 3 times negative 1. That's going to be equal to 3. That's not one that we want. 3 times 2 times 1 minus 1. That's going to be 3 times 1, 3. Nothing that we want. Negative 3, 2 times 1 minus 1. That's negative 3 times 1. That's going to be negative 3. So the ones that we want are here and here. And that's it. We ruled out all the other possible a's and b's from our preceding equations. So the only ordered pairs, A, B, are, now we just make sure we get the order right, 3 and 0, and negative 3 and 1. Okay? So we explained what we were doing at each stage, and we didn't really use any product stuff, so I would argue, at least the way we did it, 4A and 4B weren't really connected. But we plugged in the g of x. That might have been worth a mark, resolving some of that. Comparing the coefficients to get possible a's and possible b's, maybe a mark, maybe each was a mark. Because you got to remember these things are out of 10, and the written parts are usually worth more than the light bulb parts. And then maybe a mark for the chart, and then a mark for each correct answer, or a mark for getting both of them right. Who knows? I could easily see this being 5 and the light bulb being 5, or maybe this is 6 and the light bulb was 4, that sort of thing. Okay, there's nothing else to do with 4, so I think I'm ready to move on. Hopefully you guys are ready to move on. If you are, I'll see you for question number 5 in the next video. Thanks for watching.